Hello everyone, welcome back to my channel. Today we're going to solve the challenging problem from LeetCode number 1578. Call it remove max number of edges to keep graph full traversable. This is a hard problem, but don't worry, I will break it down step by step so you can understand it easily in TypeScript. Let's start. First of all, in description, we have Elisa and Bob that have an indirected graph with n nodes and 3 types of edge. First type can be traversed by Elisa only. Type second can be traversed by Bob only. Type 3 can be traversed by both Elisa and Bob. We given an array edges where each edge is represented I. Type is E, Y, U. We need to determine the maximum number of edges we can remove so that after removing the edges, the graph can still be fully traversed by both Elisa and Bob. A graph is fully traversable if, starting from any node, they can reach all other nodes. Here we have a few examples with input 4 and array of edges. The output is 2 and we remove the two edges 1, 1, 2 and 1, 1, 3, and the graph will be still fully traversed by Elisa and Bob. Removing an additional edge will not make it so. So the maximum number of edges we can remove is 2. In second example, we can't remove any of graphs. And first example, the graph isn't working because we need to add one edge to make it fully traversable. So let's go to our coding solution. First of all, we will use a data structure called union find, also known as JSON set union (DSU), to manage the content components of the graph. We will make parent array. This array keeps track of the parent or the root of each node. Rank array. This array will keep track of the deepest of the trees to maintain a balanced structure. And tag and root components. This keeps track of the number and connected in the graph. Then we use union and find operation. First, find will help us to find the root of node. With path comprehensive, we make the tree flat, which speed up the future operations. And union will help us to connect two nodes. We use the rank to keep the tree balanced. If the nodes are already connected, the union operation returns false. So let's start by defining a union find. We make class union find, make parent number array, rank number array, and component components just number. After it, we will make constructor use size number and use this for parent array from length size plus 1 and we open brackets, make lower side and I equal or more I. Its parent array where its own parents initialize. After it we will make the rank array. This rank will be equal array size plus 1. We will fill it with ones. This array is keep track of dips, and the last components will equal size to the number of nodes, size of number nodes. After it we will initialize additional functions to find the root of the nodes with path comprehensive. We will find x will be equal the number and return number. After this we will return this parent, use x triple equal to x or operator, and this parent x equal this, find this parent x. Then we make a union function of two sets. We will return true if they were connected, false is already connected. Union will have x number and y number and return boolean. Then we make constant root x, which will be assigned to this find x, and root y, which will be this find y. Then we use if statement. If root x equal to root y, we will return false. If this rank of root x will be bigger than this rank root y, then this parent of root y is assigned to root x. Else if statement will be this rank root x less than this rank root y, then this parent root x will be assigned to root y. And else we make this parent root I equal to root x, and this rank of root x increasing. After it we will make this components decreasing and return true. Now we will check if all nodes are connected only by one connection. So we will create a new function is single component which will be boolean and return this. Components equal to 1. Then we will create unified instance for Elisa and Bob. Then we will use sort edges to process the 3 types of common edge first. For each edge, depending on this type, we attempt to connect the node in Elisa graph, Bob graph, or both. And we will keep count of edges used. So first of all, we will create instance using const of Elisa, which will be equal new union find of n, and Bob equal new union find n. Also we create edges used, which we equal to 0, is sort edges to process 3 common types. First, edges sort AB, that will be equal to B first element of the array minus the first element in the array. After it, we will process each edge for const type y and w of edges, v of edges, if type will be equal to 3. After it, we make for type 3 edges, try to connect in both Elisa and both graphs using const Elisa connected, which we assign it to Elisa union of u and v, and const Bob connected be equal to Bob union of u and v, and after it we use if statement Elisa connected and Bob connected edges. We will use it, should be incremented by 1. Then we use else if statement to check type 1 by comparing them. If for type 1 edges we connect only in Elisa graph using is Elisa union, we then also edges usage to be incremented to check other races. Another else if statement will be for type 2, which is connected only in Bob's graph. If Bob union, we can edges use it incremented also, and after it we will check if both Elisa and Bob graph are fully connected and return the final result of edges. If not, we will return -1. Return Elisa is single component and Bob is single component, I will use an edge length minus edges used and minus 1. Let's run our code. Oh, looks like I make typo edges. It's pass it and submit. And daily challenging is completed. Thank you for your attention. If you have any question or comments, please leave them down below. And have a nice day.